He's also more like interested in it.
No, if see the
Is it
portion
is
is
it double?
your syllabus is too vast, boys. You don't know how much vast is your syllabus. Now see in 11th standard or 12th grade, though the CBSE is cutting off some chapters, it's very important because you children are writing your examination, right? NEET or whatever entrance examination. Or these topics are carried over there. It's easy to skip, but these basic things you should know, you should learn, right? Even in your engineering examination, right? The first semester, all these things will be carried over. Nothing is left over here. Right?
We're going to look at two kinds of friction, static and kinetic friction. Now, here's an example of kinetic friction. If I push this brick, it slides across the table, obviously, and comes to a stop. Something is bringing it to a stop. We take that to be a friction force. Now, since the brick is moving, that's called sliding friction, or another word for it is kinetic friction. Now, the characteristic of kinetic friction force is that the force always acts opposite the direction the object is moving. So the brick moves this way, the kinetic friction force is that way. All right, let's take a look at another kind of friction force. This one an example of this one is the force between the tires of a car
Hello?
and the road. Let's get this car going.
Come back and I'll let you know, sir.
Now, the force that pushes the car along the road, forward along the road, is a friction force. Now, that may seem like a strange thing to say. After all, isn't it the engine that moves the car?
No.
Well, you certainly need the engine in order to move the tires,
No,
but you need the road in order to move the car. To see why that's true, suppose I turn on the engine.
Okay.
But with no road, it doesn't go anywhere. The tires simply spin. The road provides the friction. What's actually happening when the tires are in contact is that the tires are pushing backward on the road, and the road is pushing forward on the tires. This is an action-reaction pair of forces that acts according to Newton's third law. So tires push back on the road pushes forward on the car, or on the tires. And that push force is a friction force. And in this case, we call it a static friction force. We use the word static because static implies no motion. Now, it's not that the car isn't moving, it certainly is, but the wheels are not slipping along the roadbed, at least not in normal operation. Now, here's another example of static friction. Let me put an object on this brick. If I tilt the brick a little bit, the object stays there. Well, what keeps it there? It's a static friction force. There's no motion between the bar and the brick. Now, if I tilt it enough, the bar begins to move, and so the static friction force became a kinetic friction force at that particular point. One more example of static friction force has to do with the force required for us to walk. In order to walk across the floor has to push you forward. It's a static friction force. What's happening is that your shoes are pushing backward on the floor, and the floor is pushing forward on you. Again, if that seems strange, just imagine that there were no friction between you and the floor. Maybe it's an icy surface, or maybe you're walking on ball bearings. In that case, you simply slip and fall. You don't go anywhere. So you can try as hard as you want, but you're not going to move. So you've got to have that static friction force between your feet and the ground in order to move. So static friction is necessary for human locomotion, at least the kind that we normally do.
It's Professor Dave. Let's learn we observe on Earth don't always appear to obey these laws because there are extraneous variables acting upon earthbound objects, and most of these involve some kind of frictional force. Friction is an important concept to understand, so let's go over it in some detail. Whenever an object is in motion along a surface, the surface exerts a force upon the object. One component of this force is the normal force, which is perpendicular to the surface. There is also a component of this force that is parallel to the surface, and this is called the frictional force, or simply friction. This is the force that will resist the motion of the object along the surface. Every surface has some frictional coefficient that will vary depending on its composition. To see this demonstrated, try to push a small block across some ice, and then try to push it across some sandpaper. These materials differ in their resistance to motion for reasons that relate to their composition. The smoother a surface is, the less friction it will provide. But even surfaces that appear perfectly smooth will have imperfections on the microscopic level that provide some friction. As the object moves across the surface, there are select points of contact where atoms in the object interact with atoms in the surface. And this attractive interaction hinders motion to some measurable degree, no matter how small. Let's define two main types of friction, static and kinetic. Static friction is the friction that resists the initiation of motion. If you place a block on a table and try to very lightly push it into motion, it will first resist that motion because of the frictional force operating in the direction opposite the applied force of your push. You can push harder and it will still remain still, because the frictional force will always precisely oppose the applied force. Static friction will increase until the magnitude of the applied force exceeds the maximum static frictional force the table can exert. Then the force of the push can no longer be cancelled out, and the block will begin to accelerate. This frictional force is proportional to the normal force, so the heavier the object, the greater the normal force, and the greater the frictional force. This is because as the weight of the object increases, the harder it presses down on the surface, which will increase the number of contact points between the object and the surface. Static friction is It's Professor Dave. Let's learn about smooth. Will have imperfections on the microscopic level that provide some friction. As the object moves across the surface, there are select points of contact where atoms in the object interact with atoms in the surface, and this attractive interaction hinders motion to some measurable degree, no matter how small. Let's define two main types of friction, static and kinetic. Static friction is the friction that resists the initiation of motion. If you place a block on a table and try to very lightly push it into motion, it will first resist that motion because of the frictional force operating in the direction opposite the applied force of your push. You can push harder and it will still remain still, because the frictional force will always precisely oppose the applied force. Static friction will increase until the magnitude of the applied force exceeds the maximum static frictional force the table can exert. Then the force of the push can no longer be cancelled out, and the block will begin to accelerate. This frictional force is proportional to the normal force, so the heavier the object, the greater the normal force, and the greater the frictional force. This is because as the weight of the object increases, the harder it presses down on the surface, which will increase the number of contact points between the object and the surface. The static frictional force will be anywhere from 0 to the maximum possible value, depending on the forces operating on the object, since the static frictional force will be equal to the applied force until the maximum is reached. The magnitude of this maximum can be calculated this way. F max is equal to the coefficient of static friction times the magnitude of the normal force. This coefficient, represented by the Greek letter mu, is unitless and unique to the surface in question, and we have tabulated these coefficients for a variety of common surfaces, like glass, steel, wood, and rubber, and the various combinations thereof. As we said, once the applied force exceeds the maximum static friction, the object will begin to move. Bear in mind that this equation involves scalar quantities, not vectors, and therefore implies nothing about direction. As we said, static friction opposes the initiation of motion, but once an object is in motion, it is now moving against kinetic friction. This is the force that opposes relative sliding motion. Kinetic friction is always lesser than static friction, which you will notice if you try to push any object across a surface, like a heavy box across the floor. It will be more difficult to get the box going than it is to keep it moving once you've started. There are coefficients of kinetic friction as well, and these will be different from the coefficients of static friction for the same materials. These values allow us to calculate the magnitude of the kinetic frictional force acting on a sliding object. Friction isn't always a nuisance. It can also be used to our advantage. When we walk, the static friction between our feet and the ground allows us to propel ourselves forward, rather than our feet simply sliding back. Car tires take advantage of friction to move the car forward, and they are designed with grooves to divert water away so that it does not interfere with the contact between the tire and the ground. This allows it to maintain traction rather than skidding. We should note that air resistance is another type of fluid friction. When a car or a plane moves through the atmosphere, the particles in the air hinder its motion, offering some kinetic friction. This is true of motion through any fluid, in a way that depends on the viscosity of the fluid, which represents the fluid's resistance to flow. So by now we are familiar with a few of the vectors we will commonly use in physics. An object at rest on a flat surface on Earth will experience a downward force due to its weight, as well as an upward normal force that is equal in magnitude. If some horizontal force is applied, there will also be an opposing frictional force. If the applied force is less than the maximum static frictional force of that surface, the horizontal vectors will cancel each other out, just like the vertical ones, and the object will remain at rest. If the applied force exceeds the maximum friction, the object will accelerate in the direction of the push, and the kinetic frictional force will oppose its forward motion. So we can expect to see these four vectors in lots of the free body diagrams from this point forward. A common example is the inclined plane. In this scenario, we can examine a block sliding down a ramp. Gravity, represented by mg, will pull straight down, and this vector can be divided into components that are perpendicular and parallel to the incline. Those will be mg cosine theta and mg sine theta. The force opposite the perpendicular component will be the normal force, equal in magnitude and opposite in direction. We can then include a vector for the force of friction, which opposes the other component of gravity. If we calculate the net force acting on the block, this will allow us to predict the acceleration on the block as it slides down the incline. And since the two perpendicular forces cancel each other out, we just add the parallel ones together to find the net force. To try this more quantitatively, let's check comprehension.
Boys, I think so. You got an idea of what is static friction and what is kinetic friction?
Yes.
Okay. So I'll start with the theoretical part. So basically, this is one is the voice is echoing.
Yes, ma'am. Yes, ma'am.
Yes. Okay. Then I think so. Again, I'll share the. We'll start with this once again. Types of friction. One is static friction. The other one is dynamic friction. We'll start with static friction. Okay. Look at the. We'll study what do you mean by static. Static friction means static frictional force. What do you mean by static frictional force? You can see the first example where a person is applying, you have a block, right? A wooden block, say of mass 40 kilogram, resting on a floor, right? A person is applying a force of 120 Newton. He's applying a force of 120 Newton. So that is the direction of your applied force. So he's applying a force of 120 Newton. Now you can see the block is not moving. The moment he applies a force, there will be always a frictional force which comes into play, and this frictional force will always act, right? It's a tangential force. You know what is tangential force, right? That is acting along the surface separating both the block and the floor, or what we call it as in the interface. So the moment you apply a force, immediately a frictional force will be generated, which will act in the opposite direction. Now this frictional force will not allow the block to move. That is what is seen in the scenario 1. And this frictional force, we call it as static friction, because it doesn't allow the or it stops the motion of the body. Static friction. Now look at the next case. The person now, he is increasing the applied force, say to 160 Newton. So the moment he increases the applied force, now your frictional force also increases. That is why we say your frictional force is a self-adjusting force. Some reference book you would have studied. Your frictional force is a self-adjusting force. Now, this is the case. When you increase the applied force, immediately the frictional force will come into play, and this frictional force now becomes equal to 160 Newton acting in the opposite direction. So now you can see you have applied a force of 160 Newton. Your frictional force now adjusts itself and it also becomes 160 Newton. So both the forces cancels out each other and still the body is at rest. Yes.
Ma'am, so for the first one also it's 120 newtons, right?
120.
The
Yeah,
opposite.
it is one. Yeah, correct.
Okay.
120. Here it is 160. Now let us see the third case. Now the moment you applied force, you are keeping on increasing the applied force. You keep increasing the applied force. Your frictional force also will increase so that the body will not move. Then such frictional force, we call it as static friction. Now, how far this can happen? Now, when your applied force becomes equal to 200 Newton, then say your frictional force becomes equal to 180 Newton. That's the maximum value it can take, right? That this maximum value depends upon the nature of the block as well as the surface on which the block is moving. Both the nature. Two bodies are in motion. Generally, friction is because of the relative motion between two bodies in contact. So now here the frictional force depends upon the nature of both the bodies in contact. One is the ground, as the other one is your block. Then now you have increased your applied force to 200 Newton. Your frictional force will increase, but it cannot become equal to 200 Newton. I'd say it maximum value it can take is 180 Newton. Right? Now what happens is that now the body just begins to move. Are you clear, boys? When your applied force becomes equal to 200 Newton, in this case, your frictional force also increases, but it cannot exceed more than 180. The reason is it depends on the nature of both the surfaces. Say your frictional force can take maximum of 180 Newton. Now both are unbalanced forces. So now what happens? Now the body just begins to slide. So this value of your frictional force, when the body just begins to slide, we call this maximum, Fs maximum, the maximum static frictional force, right? The maximum static frictional force that comes into play, or the maximum frictional force that comes into play the moment the body begins to move or the moment the body begins to slide. We call it as limiting friction. Is that clear between static friction and limiting friction?
Yes,
Ma'am. Yes, ma'am.
Yes. Yes.
Ma'am, at point C, even that friction is still static friction, no?
This C 200 Newton and 180 Newton. You're talking about 180 Newton?
Yes, ma'am. Is it dynamic or static?
No, it is static. Here, the condition is when frictional force becomes equal to 180 Newton, that is the maximum value it can take when your body just begins to move, right? It is not moving, it starts to move. When it starts to move, your static friction will have a maximum value, and this maximum value of static friction, we call it as limiting friction. Is that clear, or should I explain all these concepts once again? Boys? It's clear. Okay.
It's clear.
Yeah,
Fine. Okay, fine. Now, next, once the body is set in motion, once the body begins to move, still there will be a frictional force, but this frictional force will be less than 180 newtons. Say, might be 120 or what. I'm just giving a value. So once the body continues to move, right, still there will be friction between both the body and the ground. And this frictional force that comes into play as the body keeps on moving over the other surface. We call it as kinetic friction. So only two types of friction: static friction, kinetic friction. The maximum value a static frictional force can take just when the body begins to slide is limiting friction.
Ma'am,
Yes. Yes,
Yeah,
someone?
go on, John.
ma'am, in the video when the man started small car started moving, ma'am, was that static friction or kinetic friction?
The first video.
Yes, ma'am.
First video is that did he keep the car on the floor or he was keeping the car? Where did
Ma'am,
he?
like when it was moving, while it was moving.
Yeah, he told it's static friction, right?
Yeah, that's what.
Yeah, why he told it as static friction? Because this can be easily explained when you learn about what we call it as objects rolling down an inclined plane. So I'll explain over there, because whenever the tire, see, whenever an object moves, at the point of contact, net force will be equal to 0. Now you'll not understand, boys. When any body, for that, this is a rolling motion. It is rolling as well as sliding. When a car moves right on the road, you have rolling motion because your tires are rolling. Are you clear? Your tires are rolling, but the car is sliding. Sliding means moving. So you have two types of motion: sliding and rolling. When the body rolls, that when the tire is rolling, now the tire will be at a single point, the tire will be in contact with the ground. Have you seen? The tire will be in contact with the ground, say at a single point, or else might be for the smaller space. Now at that point of contact, the net force will be 0. You will understand this concept when we, I think so, rigid body dynamics might be next chapter. When we start doing it, you will understand, because we have to start understanding what we call it as a rolling motion. Right?
Okay, ma'am.
Otherwise, I have to put one. Right now, we'll start with this, and when we start with rolling motion, you will understand. Okay, static friction. And one more thing, boys, normal reaction. Whether you know about normal reaction or not, I'll go for one more slide. I'll explain normal reaction. Now, what do you mean by normal reaction? Generally, whether you stand or whether you sit on floor, right? Say if you're standing on the floor, you will exert a force on the ground. Yes or no? When you stand on a floor on the ground, you are exerting. Are you not exerting a force on the ground?
Yeah.
What?
Yes, ma'am.
And the force you exert depends upon your weight. The force you exert depends on your own weight, right? So now what happens is that we are exerting a force on the ground. Have you seen anyone sinking into the ground? Everyone, for that
No,
matter.
ma'am.
You don't sink. Now, what is the reason? The ground is going to exert an equal amount of force on you in the upward direction. Such force we call them as normal reaction. Was very, very important. When later on you will be using your what we call it as resolution of vectors. This is helpful, right? So look at the diagram. A block is resting on a table. You consider a block which is resting on a table. Now it is going to exert a force on the table which is equal to its own weight, right? Then the table will exert an equal amount of force on the body, which is acting in the upward direction. We call it as the normal reaction. And this, suppose if the weight of the body is 40 Newton, your normal reaction will also be equal to 40 Newton. Yes or no, boys?
Yes, ma'am.
Yes.
Yes, ma'am.
These are balanced force. That is why your block remains at rest. Your block is going to remain at rest because these two forces cancel out each other. Boys, think that you're not only learning to move on to grade 12, because most of you are preparing for SAT, for entrance. So these are the basic concepts, very important, boys. As you learn, I know continuous 2 periods, 3 periods is tough, but still. So this is
Ma'am,
what
they don't act on the same point.
they have to act in the same point. I think the diagram is slightly different. They have to act along the same line. The line of action should be the same, especially in this. Especially in this case. Yeah, especially in this case, but not in this case. In this case, you have to resolve. Let us see later, we'll resolve that. Okay, because I want this normal reaction to be done again. Now look at the stats. No, normal reaction long back was normal reaction. I had given you long back, right?
Yes, ma'am.
Okay,
Yes.
now we'll go.
I did check.
Okay, now yes, boys. Now we'll go for static friction, right? Now you can see a car. A man is pushing, right? He's applying a force. This is the direction of the applied force. The car is.
Shall we copy it down?
Boys, you tell me whether you want to copy it down right now or you want to copy it later.
No, that's fine. You can upload the PPT.
Okay. But you people will take care of writing, right?
Yes. Yes, ma'am.
Theoretical.
Better than PPT.
Okay, you want to write? Then I'll read it out. So now look at this. The person is applying a force on the car, right? In that case, there will be a frictional force between the tires and the ground acting in the opposite direction. That is Fs, static friction. Both the forces will cancel out each other and the car is not moving. And such frictional force, we call it as static friction. Is that clear, boys? So the car is exerting its own weight in the downward direction. The car is exerting a force on the ground, which is equal to its own weight in the downward direction. Then the ground, Newton's third law of motion, the ground is exerting an equal amount of force on the car in the upward direction. That is what we call it as normal reaction. Is that clear, boys?
Yes, ma'am. Yes, ma'am.
Shall I move for limiting friction, or you want to write the statement of? I think you don't require to write. Just I'll go for limiting friction. Now look at the limiting friction. The force of friction which comes into play when a body just starts moving over another surface is called the limiting friction. So that is, you are applying a force on a body. There will be a frictional force acting. The moment you apply a force, there will be a frictional force acting on the body. And if the body begins to slide, then the maximum value of the frictional force that comes into play, we call it as limiting friction. We denote it by Fs maximum, the maximum value a static friction can take, so that the body just begins to slide. We call it as Fs maximum. Are you clear with limiting friction? Are you clear?
Ma'am?
Should I redo? Yes?
Ma'am, if all these forces are concurrent, then how will F net become greater than 0?
No, it's not concurrent, boys. Frictional force is not concurrent. Okay, suppose if I have a body, I have a block placed on, placed on a surface. Now I'm applying a force. Look at the applied force. Now this is a horizontal force. I have applied an force on the block, but where is your frictional force acting? Your frictional force will always act, right, between both the surfaces in contact. Tangential force. This is frictional force. Are these two forces coinciding each other?
No, ma'am. All right.
Yeah, so it's not a concurrent force. Yes.
Ma'am, can the weight of the object be more than the normal reaction?
No. Now, what happens? You tell me, if the weight of the object is more than the normal reaction, what will happen?
And suppose we sit on a chair and the weight of us is more than the normal reaction of the chair. Will the chair
then
break?
it'll break. Yeah, it'll break. That's what.
Yes, ma'am.
Now, kinetic friction is this. The body is now set in motion, right? You have applied a force, now the body starts moving. Even as the body starts moving, there will be a frictional force. And such frictional force, we call it as kinetic friction. Are you clear? So once the body is set in motion, then the frictional force between the two bodies in motion, we call it as kinetic friction. There are two types. One is sliding friction. That is you're making say a car moving along a road or a toy car moving along a surface. All these are sliding friction. And you see seen rolling friction also, right? Along an inclined plane. If I so suppose if I keep a metallic sphere on an inclined plane, what happens? The sphere keeps rolling down. This is still there is a frictional force between the sphere and the inclined plane, and such frictional force we call it as kinetic friction.
And what happens to static friction in quicksand?
Static friction in static friction in
Quicksand.
quicksand. In quicksand, will the vehicle be able to move?
No, ma'am.
It's not going to move, right? So it's
Yes.
still static friction.
But then it gets sucked into the ground, no, but
So you mean the tires will not be rolling on?
yes, ma'am.
So then there will be no static friction at all. It depends. See, whichever frictional force, whether it is static, limiting, or kinetic, it depends on the nature of both the surfaces. So you have to check the surface quicksand. How is that quicksand? It's compared to other surface. Quicksand is, you compare quicksand with a concrete surface. Okay. So now very important is, yes.
Can you explain the kinetic motion? I mean friction. Like I was disconnected, so I couldn't listen.
Okay. Kinetic friction is that once the body starts moving, right? You have applied a force. So now what happens is you keep increasing your applied force. So at one point the body starts moving. Once the body starts moving, then the body cannot see. You're rolling an object on the ground. You would have seen the object keeps on rolling. After some time, the object comes to a rest. Now, why does the object comes to rest? The reason is there is a frictional force acting between the object and the ground, right? And such frictional force set in when the body is in motion. We call it as kinetic friction. So when the body is in motion, the frictional force that comes into play, we call it as kinetic friction. So this kinetic friction is of two types. One is sliding friction, that is one body sliding over the other. Then rolling friction, one of the two bodies rolling over the other. That's it. That is about kinetic friction. Then,
Okay, ma'am.
boys, we'll start with the laws of limiting friction, right? Now, is that the frictional force? Someone just now asked about the quicksand. Who was that? May I know who asked about?
Ma'am, Surya.
Surya. Surya, we'll see how different surfaces are going to produce. So going to affect your frictional force. Is that the frictional force depends upon the surface? Naturally, it will depend. It will depend on the surfaces. So Surya, you read out these before I go for the video clipping for this.
Limiting friction is the maximum friction that can occur between two surfaces in contact. Limiting friction is directly proportional to the normal reaction between the surfaces. Limiting friction decreases with the smoothness of the surface.
Okay. So these are the 3 points. Out of this, let us see how is your limiting friction is going to change when the smoothness of the surfaces are going to change. I'll just
This experiment tries to investigate the effect of surface. This experiment tries to investigate the effect of surface, the type of surface on friction. So we are going to test on a few material. One is on a cardboard material, paper. Two, plastic. There's a layer of transparent plastic here.
Is the video audible? 11B?
Yes, ma'am.
3, sandpaper, and 4, leather. Okay, the experiment begins with plastic material. So at the other end of a string, there's a pen. And inside the box, we place the 50-gram mass. Okay. Let's begin with adding 1 washer. Take note that a hand should be supported below the pen so that there's no impact on the pen to make it move. 2, 3, move. Okay. Normally we'll do this type of experiment 2 times so that we can have a more certain answer. 1, 2, and 3. Okay, move. Now we change the surface to sandpaper. The weight 50 gram remains the same. Let the weighing begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it has already moved, so the number is 10. The third material is the original material, the cardboard, which is this one. Let the weighing begin. 1, 2, 3, 4. The last material is leather. Again, we have a 50-gram mass inside, and this is the leather. Measure 1, 2, 3, 4, 5, 6, 7, 8, 9,
11B, you can see the PowerPoint presentation.
No, ma'am, you're not showing.
Oh, okay, fine. Anyway, I'll just show the PowerPoint presentation. Before that, what did you understand from this video clipping? Now, how do you measure your frictional force? Generally, in such experiments, the frictional force, that is the limiting friction, what he's measuring, see, he added the weights in the pan, right? Have you seen he was adding the weights in the pan? This weight which is being added is nothing but the force that is going to pull the object forward. So you measure your limiting maximum frictional force because the object was just beginning to slide. So then the frictional force that comes into play is your limiting friction. That is the maximum static frictional force can take a value. So maximum static frictional force, in other words, what we call it as limiting friction. So whatever weights he has added in the pan, that is a measure of your frictional force that is acting between the two surfaces, one moving over the other. So have you seen the frictional force were different? Are the weights added in the pan were different? Were the weights added in the pans were different or the same?
Different.
Different. See, keep this in mind, boys. This experimental setup, right? He was measuring the frictional force in such experimental setup. Even in the laboratory, you will be doing an experiment on frictional force. Same way, you will be doing a similar experiment to find coefficient of friction. I'll come to coefficient of friction later. So you can measure your frictional force, right? He was adding some weights in the pan. The weights in the pan gives you the measure of the frictional force acting between the floor and the object, right? So when the surface, nature of the surface were different, he had used a cardboard surface, he used a sandpaper, leather as the surfaces. You could have seen for various material, your frictional force were different. The added weights were different or not? Why?
It was different.
Oh, yes, ma'am.
So that is one important thing. The frictional force between any two objects in relative motion depends upon the nature of the surface. Second one. Okay, let us see how is your frictional force is going to change with the mass of the body. Right, boys? Nature of the surface we have already seen. In sandpaper, it gives a maximum frictional force. Have you noticed when the surface of the moving object was fitted with sandpaper, was the friction force maximum?
Yes, ma'am. Yes, ma'am.
Yeah. So it depends upon the nature of the surface. Now let us see how is your frictional force is going to change with the mass of the object. There's no volume coming up. 1 second. There's no volume. I think this clipping is not having any audio. Let me check. Boys, is it fine if I go without audio?
Sounds fine.
Okay.
Ma'am, can you start it from first?
So you're going to study how is your frictional force is going to change with the mass of the body. Now, how do you measure your frictional force? You measure your frictional force by weighing all the by weighing the weights you're adding in your scale pan. You could have seen a scale pan over there. So you keep adding the weights. The weights added in the scale pans is just a measure of your frictional force. So whatever you add in is, yes?
Ma'am, we are not able to see the video clearly.
Okay.
And so can I send the link? Then everyone can watch it.
That can you do it after the class? That you can do after the class. I'll just complete this because I have to start with the laws of limiting friction. Now you're increasing the weight of the object. When you increase the weight of the object, see the value of the limiting friction. Now it becomes your limiting friction is proportional to 10 grams. So for lighter weight, so for the lighter block, you require 5 grams to pull the block. For heavier one, naturally you require 10 grams. So these are a direct proportion for your limiting friction. So the force of limiting friction is directly proportional to normal reaction. What about normal reaction? Normal reaction was what they have stated is so on glass top, you need only 5 grams to pull the object, which means on a smoother surface, your object can slide at a faster rate because your frictional force is very less. So limiting friction reduces with the smoothness of the surfaces. It is directly proportional to the normal reaction. Right. So we'll start with the laws of limiting friction. Right, boys. The limiting friction, the limiting friction means the frictional force. The frictional force that acts between two surfaces when one body just slides over the other. So that is what it means. The limiting friction depends on the nature of the surfaces in contact. Anyone who still has a doubt in this statement, boys? 11B, anyone is having a doubt in this statement? The limiting friction depends on the nature of the surfaces. Right? It depends on.
No, ma'am.
Right, because these laws of limiting friction is important. Please do write. The limiting friction depends on the nature of the surfaces in contact. If the surfaces are smooth enough, then your frictional force will be less. Next one. Where does this frictional force act, boss? The frictional force acts tangential. You know what is tangential, right? To the two surfaces in contact, and in a direction opposite to the direction of the motion of the body. You know what is tangential?
Yes, ma'am. Yes, ma'am.
I can hear 11B, only 2 students are responding. Where is Kritya? Kritya is absent?
Ma'am,
No,
it's
I'm here.
echoing.
There. Where is Jopal?
Yes, ma'am. Yes, ma'am.
All is here.
Mama, voices are echoing.
Yes. Samuel?
Mama, voices are echoing.
Okay. Second. Is it fine now? Is that fine?
Yes, ma'am.
Okay.
Yes, ma'am.
So always your frictional force acts tangential to the two surfaces in contact, but it will be always acting in a direction opposite to the direction of the motion of the body. And very important is independent of the area of the surface in contact. Let it go as a homework. You check how is your frictional force is independent of the area of the surfaces in contact. Check by yourself. At least one area you learn, boys. Siddharth is here, okay. Samshul? Shushal, microphone is not working. Shushal? Now, what is very important in laws of limiting friction is this. Please understand this, boys. All your numericals, whatever you are going to solve next, you will be using this concept. Are you clear? Now,
Yes, ma'am.
in your previous, boys, in your previous video clipping, you have seen that when you were using a 50-gram weight, sorry, you are pulling an object of 50 grams. Suppose if I pull an object of 50 grams, say the frictional force, I have an object, say of weight W is equal to 50 Newton, weight is measured in Newton, your normal reaction N also will be equal to 50 Newton. So your frictional force, say that is your limiting friction, that is when the body just begins to slide. Say if your frictional force is say 10 Newton. Now when you increase the weight, say when you increase the weight to 150 Newton, your normal reaction will also increase and your frictional force is also going to increase. So that is what it means. Are you clear, boys? When the body becomes heavier, are you clear? When the body becomes heavier, you have to apply more force to pull the body. In that case, your frictional force also will increase. So this is a very, very important concept. Please understand, when the weight of the object increases, then the normal reaction should also increase. Do you understand what is normal reaction and the weight? Weight is that the force exerted. When you're standing, you're exerting a force on the ground, and the force you exert depends upon your weight. Naturally, the ground will exert an equal amount of force on you in the upward direction. That is what we call it as normal reaction. So when the weight of the object increases, normal reaction is also increasing, so that your frictional force also increases, because when the weight increases, to move the object, you require more force. So your applied force increases. When your applied force increases, your frictional force tends to increase. That is why Fs maximum, the maximum static friction, the frictional force that takes place when the body begins to slide, Fs maximum is proportional to normal reaction. Normal reaction is proportional to the weight of the body. So when the weight of the body increases, the normal reaction increases. when the normal reaction increases, the frictional force is also going to increase, right? Now, you know what you mean by constant of proportionality, boys? You know what is meant by constant of proportionality? Proportionality?
Yes, ma'am.
What do you mean by that? Okay, right.
Usually where it doesn't depend on any other factors.
See, suppose if you go for if you go for F is equal to m into A, right? What is the this is the concept. Force is proportional to acceleration. Do you agree with this? When you apply a force on a moving object, will it not get accelerated? You use your accelerators. While driving, you use your accelerators. Why do you use your accelerators? You're applying a force.
Accelerate the car.
Yeah. So you apply a force. More the force you apply, will not the speed increases to a greater extent, then we say the body is accelerating? Yes. Is that clear, boys? So F is directly proportional to A. Now look at the constant. M is constant of proportionality. Now what does it mean? If I increase the force, say if I'm increasing the force 5 times, I think so in accelerators you can increase the force. Because while driving the car, you use your accelerators. Do you increase the force? Something related to gear or some? I'm asking you. You have the gears, first gear, second gear. What do you mean by first gear, second gear, third gear?
Like, yeah, as you increase the gear, you would the capacity of like the maximum speed increases. Like if
then you are
you
applying more
increase
force.
gear,
Correct.
like the limit of the maximum speed, like there's a limit to each gear.
And more importantly, it increases the amount of force that the engine exerts on the wheel.
Exactly.
That is your accelerators. Actually, cars are having accelerators where you have different gears. I have to learn from you.
Manual transmission.
Okay. So now look at this, boys. Say when I'm increasing the force, say 5 times its initial value, it is not necessary the acceleration should increase 5 times. Are you clear? Directly proportional means what? When F increases, A is also increasing. But if F increases 5 times, not necessary A should also increase by 5 times. It might increase 10 times, or it might increase by a factor of 3. It might increase 3 times its original value. Now the mass of the object, right? The mass of the car determines to what extent your A can increase. When the force is increasing, acceleration is also going to increase. But by what factor your acceleration is going to increase depends upon the mass. That is why lightweight cars move faster when you put your accelerators. Yes, boys?
Yes, ma'am.
Lightweight cars move faster when you accelerate. Or the heavier one moves faster.
No,
the lightweight one.
That's it. So the mass becomes a factor over here. Okay? And let us see that. So Fs maximum, that is what we call it as mu s. Have you heard of, are you familiar with this, this symbol? Are you familiar with this symbol?
Yes, ma'am.
We call this mu. In optics, this term is used to indicate a refractive index of a medium, right? So different branches of physics has different identity. So here the constant of proportionality is mu s, which means when the normal reaction increases, to what extent your frictional force is going to increase is indicated by mu s. Very, very important is this. Boys, whenever they go for this, especially the racing tracks. Have you seen the racing tracks? This car racing tracks, right? So when they make those floors which are for the racing tracks, what they do is that generally your cars are the tires are made up of rubber, special. So then these rubber tires have to move over the racing tracks. So then you have some particular tracks. Say I'm going for concrete track, but anyway, they don't use concrete track. So these two materials, right? They will check for these two material, what is the value of mu s. This value of mu s indicates whether the surfaces are smooth enough so that there is less friction. If value of mu s is low, is having a very low value. This value of mu s is for two different materials, because you are talking about friction. Friction means it's a relative motion between two objects. There will be friction only when one object slides over the other, or both the objects are sliding over the other. So for friction, this concept is very, very important, mu s, right? So they will check both the materials, what is the nature of the material, and they go for this value, what we call it as mu s. Accordingly, they will select, even for rubbers which are used for tires, there are different type of synthetic rubbers. So they will check with the concrete material on the concrete track as well as these rubber material, so that the value of mu s should be as low as possible. Only those two materials will be taken for car racing. So all this comes in mechanical engineering when you go for selecting, see, even for tires, even for the normal cars, when they go for fabricating tires, there is what we call it as electrical hysteresis. I don't know this time, this year, whether they have. You'll be studying in next volume 2 of your physics, where you have properties of solids. You will be studying your electrical hysteresis. So how much is we have magnetic hysteresis in magnetism. That is, all your transformers are made up of iron cores. There we'll go for which material to be selected for fabricating your magnets. Here, electrical hysteresis is when you make your car tires, when you fabricate your car tires, you have to select a material, right, which has less electrical hysteresis. So these are all the factors which are very important. Anyway, now you start with this, boys. You complete this. Now this constant of proportionality, mu s, is called coefficient of limiting friction. This is very, very important when you solve your numerical.
Ma'am,
Yes,
when you're talking about the nature of the surfaces in contact, that point means the coefficient of limiting friction.
So for both the surfaces, they will have a value of s. Let me see if I can get a tabular column. You'll understand it better. Shall I move for the next slide?
Yes.
Boys, is that continuous 2 periods is tough for you with all this theoretical part? Okay.
No, ma'am, it's fine.
Boys, one second, I don't know. Yes, it's totally theoretical.
Yeah, ma'am, it's kind of tough, but we'll get it with practice, I guess.
Look at the tabular column, boys. So static and kinetic friction, a steel object moving over the steel surface, then the static friction is 0.58, kinetic friction, you can see, look at the values of static and kinetic friction. Your kinetic friction, F suffix K, is always less than the static friction. That you should understand. For various materials, now look at this, the value of mu tells you if the value of mu is having a lower value, then both the surfaces are smooth enough. If the value of mu is more, then it indicates a rough surface. So this is very, very important in the concept of friction. Now comes, you have to study about, angular friction angle of repose, relation between angle of friction and angle of repose. Now comes only your theoretical one where you have to start drawing your diagram. Fine.
Ma'am?
Yes?
You'll be uploading this, right?
No, I'll do that. But angle of friction is very important. You have to draw the diagram and you have to start writing. Now look at this, boys. Statement is very important. Now, what do you mean by angle of friction? Angle of friction is defined as the angle made by the resultant frictional force and the normal reaction with the normal reaction. Statement is confusing. Just look at the diagram. Right. Now you have a block, right? The block is, say, on the surface, on any surface, say it is on the surface of a table, right? Now you are applying a force. You have applied a force. You want to pull the block. So now the moment you apply a force, the body, say, just begins to move. You have applied a force. The moment you apply a force, say the body just starts to slide. And when the body just starts to slide, the frictional force between both the objects is what we call it as limiting friction. So that is what Fs maximum. Now this frictional force is going to act in the opposite direction. Actually, this should be along the, it should be along the tangent, but for mathematical purpose, yeah, just, so this is your applied force. This will be the direction of your frictional force. The body is just about to slide. Now, you know this, the weight of the object is acting downwards. Instead of R, I'll just put it as N. There will be an equal amount of force exerted on the block by the table. We call this as normal reaction. Is that clear? Can you identify all the forces, boys? Then I'll go for the mathematical calculation of angle of friction. Boys, the block is on the table. You have applied the force. Now the block just begins to move. When the body has just started to slide, the frictional force that comes into play, we call it as limiting friction, the maximum value your static friction can take. So this will be the direction of the frictional force. This is the direction in which the body is moving. Then you have the other two forces, weight acting vertically downward, normal reaction acting vertically upward. Yeah. Now what is your angle of friction? The angle of friction is defined as the angle made by the resultant of frictional force and normal reaction. Boys, this is your frictional force and this is your normal reaction. Things are difficult, just listen, and then next class you can take the diagram later on. Boys, this is your normal reaction, right? This is your normal reaction. This is your frictional force. These are the two vectors. Now these two vectors are acting along the sides of a parallelogram. Then where will be the resultant acting? This is the resultant. Is this not the resultant?
Yes, ma'am.
Okay. So this is the resultant of the frictional force and the normal reaction. This is one part of the question, statement. Angle of friction is defined as the angle made by the resultant of the frictional force and the normal reaction with the normal reaction. So this is the resultant. The resultant is making an angle theta with the normal reaction. So the resultant of frictional force and the normal reaction, this is the resultant, right? This is inclined at an angle theta with the normal reaction. This angle, we call it as the angle of friction. Anyway, it's time up, boys. You can.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Should I put this in? I know, it's 120 you want to run. Okay, I'll put this in your file section in physics.
Yes, please, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Boys, boys, you yourself tell. Let me know that in case if next week we are not very sure whether the students who have opted for blended learning will be visiting school or not. If that is the case, then practicals, I'm not very sure practical we can proceed with the practical class. Then it would be a theoretical class, theory class. So in what way should I?
That's fine.
It's fine.
Yes,
Then in that case, one of these period I'll put for purely for textbook numericals. We'll go for textbook numerical last period.
Sure.
Fifth period.
Anything is fine.
All right, ma'am.
Thank you, ma'am.
Thank you, ma'am.
I'll just put this
Thank you.
slide. But please copy down the angle of friction, because tomorrow for you to copy it will take five more minutes. So what I'll do is I'll put this slide, PowerPoint presentation in physics file section. At least limiting friction, kinetic friction, static friction definition you people do right. Then laws of limiting friction is very, very important. And this till angle of friction you complete your work, boys. Thank you. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.